All right. Okay. Number 18. Number 18 is pretty much almost exactly like one of the quiz problems for Thursday. So definitely lock in. Make sure you understand what's happening in number 18. Evaluate each geometric series. Evaluate means find the sum. And I really want to point out that this particular geometric series is finite. Let's talk about the word finite again. Finite means it has an ending. And I can tell it has an ending because it's going from term 1 to term 7. Okay. And the reason I'm saying that is because the finite ones have a different formula from the infinite ones. And the formula is sum equals first term times r to the n minus first term over r minus 1. Again, that will be printed at the top of your quiz, but you do need to know that that's the correct one to use, which I don't think is too big of a deal. Okay, what I'm going to do over here is I'm going to list the 3 things that I need to fill in my formula. And the first thing I notice is that my exponent is letter minus 1. Because the exponent is letter minus 1, that means the first term is the number in front of the multiplier, which is -4. That's the way they are most of the time. The multiplier is -6 because that's the base of the exponent, so that's what keeps repeating. And then the number of terms in this problem is 7 because it's telling you to go from numbers 1 to 7. You guys have any questions about that? So the clue here is just identify which thing is which. Okay, then we fill in sum equals first term times r to the n minus first term over r minus 1. Okay, now this is important. Make yourself do this in the calculator because there's a couple of very important things here. Don't mind that stat stuff from last period. What I'm going to do is I'm going to do -4, and then you have to put that -6 in parentheses in your calculator. Otherwise, it's going to do the order of operations in the way that it thinks is right. And then right here, this minus -4, I'm going to put +4. Does that make sense? Okay, so I have 1,119,748. And then I hit enter, and then I'm going to divide by -7. -159,964. Not a hard problem. Pretty easy. It's just you got to be careful with the parentheses in the calculator, and you have to be careful with just picking the right thing for the right spot. But other than that, it's not too bad, I don't think. You guys want to ask or say anything about this one before we move on? Good? You sure? Okay. All right. Now let's do number 20. Now I have a fun question. On the mid-chapter worksheet that should be done. However, I'm wondering if any of you have 15 and 16 blank. Look back at your mid-chapter worksheet and tell me if you left 15 and 16 blank. It might be the only 2 that you actually left blank on the whole thing. So I'm hoping that this will help. This problem is just like number 15 and 16 on your mid-chapter worksheet. Okay, And we're going to use the same formula from number 18. Everybody okay with that? You guys with me? Okay, so I'm going to use the same formula and I'm going to fill in the pieces. Negative 182 is the sum. So negative 182 equals first term. Okay, stop right there. What's the first term when there's nothing in front of the parentheses? 1. So put yourself a little 1 times right there. Oh my, he comes in with a bang. Okay, what is R in this problem? -3. We put that in parentheses. Be very careful. N is what we're solving for, so that's going to stay a letter. Minus first term is 1. Are you guys with me? Are you sure? I'm just following this. So sum equals first term times R to the N minus first term over R minus 1. Okay, everybody good so far? Okay, first thing I'm going to do is make the bottom -4. So negative 182 equals 1 times -3 to the N minus 1 over -4. Okay, now I want to get rid of the -4, so I multiply both sides by -4, and that crosses out the denominator. Don't multiply any of this stuff by -4, just this. Are you guys with me? Yes, Mrs. Hammond, you're so with me. Okay, add 1 to both sides. Okay, now in this spot, having the 1 is unusual. I'm going to divide by 1 on both sides. It's completely unnecessary because you know 729 divided by 1 is 729, but usually that's not 1. Usually you have to divide by whatever that is. So I'm just going to do it. Okay, and now I have a squirrel in the tree problem. I have to log both sides and bring the n in front. Okay, and I hear all of you guys really amazingly putting this in the calculator. It's just that it's not going to work. I hear the tapping, the calculator tapping, and you guys are awesome, and I really appreciate it. However, what's wrong with this picture? Does anybody? Yeah, you can't log a negative. Okay, this is really weird, and we always tell you to like don't ignore stuff. This is the one time when you're doing these problems, you have to ignore the negative. Yeah, because n has to be a positive whole number. So you just have to ignore it. I know, I know. In math, we've told you a million times, like don't overlook stuff. This time you have to ignore it. And I'll explain why it's still okay in a minute, but just trust me for the second. My talbotometry that I'm teaching over here. But I got a whole number answer. I promise you that I did not put on a quiz or test ever one that you have to do ignore the negative. I'm just bringing this up now. Technically, we really shouldn't log both sides here. Instead, I'm going to get a different color. What you should do is say that (729) is -3 to the 6th power. You guys remember when we did the same base exponentials? We should solve this with a same base exponential and not a log, but we're just too lazy to do that. I don't want to sit on my calculator and go -3 to the this, -3 to the this, -3 to the this, when I can just ignore the negative and do the logs and figure out what it is backwards. Again, you'll never need to do that for anything other than homework or worksheets, but I just wanted to bring up that that is possible. Okay. So now do you think you can handle number 15 and 16 from the worksheet, hopefully? Okay. Now if you guys could grab your notebook. We need more Pascal's triangle practice. Okay. All right, so this is basically the same thing as yesterday. We're just doing more practice. I combined two problems into one because it flows better. So we're just gonna keep practicing what we learned yesterday, see if you guys remember. And then what we're gonna do is start throwing in things that are not A and B, kind of like we were working on the quiz review. Okay, so first question is, if I'm working on A plus B to the 5th, what row am I in? Row 5, great. Row 5. Okay, and I'm going to practice creating Pascal's triangle up to row 5 over here in this space. So row 0 has a 1. Row 1 has a 1 and a 1. That part you kind of just have to memorize. If you just memorize the fact that it always starts with a 1 and ends with a 1 and it goes in a triangle shape, should help. Okay, and then row 2 has a 1. Then you add these two, so 1 plus 1 is 2, and then ends in a 1. Starts with a 1. 1 plus 2 is 3. 2 plus 1 is 3. Ends in a 1. Starts in a 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Ends in a 1. 1, 5, 10, 10, 5, 1. Any questions about how to get Pascal's triangle? Okay, so that means our leading coefficients are 1, 5, 10, 10, 5, and 1. Any questions so far? Okay. Now we're going to expand. So I'm going to put equals because we're expanding this. And we're going to start with the leading coefficient of 1. Front seat is A to the full power of the problem. Back seat is B to the 0. The A's are going to go down. The B's are going to go up. So plus 5. Front seat down a power. Back seat up a power. 10. Front seat down a power. Back seat up a power. 10. Front seat down a power. Back seat up a power. 5. Front seat down. Back seat up. 1. Front seat down. Back seat up. And you can stop and just check yourself. Go, okay, 1, 5, 10, 10, 5, 1. Look at the A's. 5, 4, 3, 2, 1, 0. Look at the B's. 0, 1, 2, 3, 4, 5. Just a little check. Make sure. My life hack from yesterday was to put little bins in between the pluses to help your brain organize. Because sometimes, for some of us, all of those things can run together, look like one big giant thing. And then I'm going to cancel out anything that's 1. So that, 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 and that. And then I rewrite it pretty. So A to the 5th plus 5A to the 4th B plus 10A to the 3rd B squared plus 10A squared B to the 3rd plus 5A B to the 4th plus B to the 5th. This has 2 names. I will refer to this as a Pascal's triangle problem. It's the actual proper name for it, though. It's called binomial expansion theorem. Pascal was the guy that came up with the binomial expansion theorem. So we'd like to give him credit. Do you guys have any questions about that? That's basically where we left off yesterday. Are you completely sure? I'm totally open to any questions whatsoever. Okay, now we're gonna do a little bit of kind of advanced stuff with number 156, 157. I have to tell you, I think 156 and 157 are actually pre-calc problems. They're not really math 3 problems. You might see them in your homework. You probably won't see them on a test or quiz. These are really next year. But that's okay, because Miss Rice said that when she was teaching this in pre-calc the other day, everyone was super happy because they knew how to do it. So nothing wrong with happy. Okay. So number 156 looks kind of stupid. It says, can you tell me the third term of a plus b to the fifth? Sure I can, because I already did the whole thing. So I can easily tell you what the third term is. The third term is this one. Okay, my goal for number 156 is to tell you how to get that answer without expanding the whole thing. So this is a shortcut of a shortcut. This is a shortcut. This is your shortest, shortorama sheet shortcut. If I only need to find the third term, can I use a pattern to help me figure out what to do? So I'm going to show you a pattern you can use to just find one of the terms without having to find the whole thing. Okay, to do this, I'm going to use my resource page. You guys do not need to find yours. We'll just use mine. And I want to show you the top where I went from the fifth row of Pascal's triangle backwards to the work. Do you guys remember we filled out the table with the combinations in it yesterday in number 151? Can you guys tell me which one of those combinations refers to the problem that we're working on in number 156? Okay, so the problem says the third term in the fifth row. Does that make sense to you guys? If you're reading that, can you read third term of the fifth row? Okay, the third term of the fifth row is this one. What I really want to gain from this is that you notice that the first term has a 0, not a 1. That's the whole point of this right now. So can you guys tell that 5C2 is the combination, the word that gave us the 10 in the Pascal triangle? Okay, so write on your paper 5 combination 2. Okay, and let me get my other color. I'm going to tell you where I got these numbers from. So this is row 5. That's not a big deal. You can see where to get that from. And this I got from doing 3 minus 1. Why is it 3 minus 1? Because each row starts with 0, not 1. So I got to go down a spot. 5 combination 2. Okay. Now, this is really bad, but you can find the combinations all living in your calculator. If you could grab your calculator and hit the math button. The math button's like 2 down from the second over here. Scroll over to probability. Oh, they've been there the whole time. If you have a new calculator like this one, you can go to NCR first and type 5 combination, not 52, not 52. We don't want 52. We want 5 combination 2. If you have an older calculator, what you're going to have to do is type the 5 first, then hit the math button, then NCR, and it will plug the little 5 in there for you, and then hit the 2. And it won't look like it plugged it in, but it will, I promise. So that's where my 10 comes from. What? And I know you already know it's 10. Okay. Now, how do we get the letters? So we want a cubed b squared, correct? Okay, what I do is I put the front seat thing and the back seat thing. And the backseat one has to match whatever R is in your NCR. So these two guys will always match. And then this guy has to be 3 because all of the exponents have to add to the total of 5. Okay, so 5 combination 2 is 10. A cubed B squared. Okay, now we're going to do one that is down in the 11th row. And we're not going to make the 11th row. We're going to resist the urge to make a gigantical Pascal triangle. We're not doing it. We're going to use our pattern detection and our pre-calc brain to just do only this amount of work. That'd be great. It's the lazy. It's lazy squared. It's trip laze. Like you're so lazy you can't even say the Y in lazy. It's laze now. The word's no longer lazy. It's now laze. Yeah. Because that makes more sense. If you're lazy, you wouldn't say the whole word. Just saying. I'm a lazy human being. I like the couch. My sport is the remote. And township. Don't forget township. None of you find me fun. Okay. All right. So let's do these two. We know we're in the 11th row, so it's going to be 11 combination something. Is everybody okay with that? So I'm going to start with that. I am in the 11th row, so I'm going to be 11 combination something. And because it's asking me for the 5th term, I go 5 minus 1 equals 4. Remembering that that row starts with 0, so it's not going to be 11 combination 5. It's going to be 11 combination 4. You guys good so far? Okay, now I write my front seat and my back seat. My back seat has to be to the exponent that is the same as R in my NCR. And the front seat has to add to the total of 11. It's really not that bad. Okay, now let's go find 11 combination 4. It might be terrible. Oh, it's not bad. 330, A to the 7th, B to the 4th. Okay, now for B and number 158, which is actually our last problem of the day. I know, great. I'm gonna give you guys time to work on your 15 and 16 and your quiz review and the things after this. We're gonna start working with stuff that's not A and B. So that's the last piece of this, is being really careful when I have stuff in the front seat, stuff in the back seat that's not A and B. Notice I chose 5 and 11 again, so I would only be changing up a couple pieces of the problem. Okay, are you guys ready? All right. I noticed that the exponent is 11, so I'm going to have 11 combination something. I want the 5th term. So I take one off because the row starts with 0. So it would be 11 combination 4, not 11 combination 5. Okay, now the only difference here is when I do my front seat and back seat, I'm going to put them in parentheses. And I'm going to make sure that if it's subtraction, that back seat gets the negative. Okay. The back seat exponent has to match. Front seat exponent has to add to the total. So I have 330 times x to the 7th times 16. Which is that many feet in a mile. 5,280 x to the 7th. Mrs. Talbot, why did you leave so much room in between number 157 and 150? I don't know. I don't know. Okay, now number 158. If I lost you anywhere in 157, again, that's pre-calc, understandable. Number 158 is very, very, very much like the one on your quiz. So tune me back in. I don't know that I lost anybody though. You guys are doing good. You know, research says that the best time to have math class is 9 a.m. because you're not super tired, but you're not burned out yet. Okay, so let's pretend that Mrs. Talbot is taking the quiz. Are you guys ready? Okay, first thing I do is I walk up to this problem and I say, okay, I could do boxes if I panic. I'm not going to do boxes because I'm not going to panic. You can do boxes if you like. Okay, and it's cubed, so it's not that bad, but I'm not going to do it. Okay, I notice that it's cubed, so I'm going to say row 3. And I'm going to say 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. How do I know that it's row 3? Because it's the one with the 3 in it. Scientific stuff. Okay. All right, then I say, okay, 4 terms, 1, 3, 3, 1. So I start with the 1. Front seat in parentheses to the full power. Back seat to the 0. Plus 3. Front seat down. Back seat up. Plus 3. Front seat down. Back seat up. Plus 1. Front seat down. Back seat up. Since I really, really care about my grade, I'm going to check and say 1, 3, 3, 1. Look at my front seat exponents, 3, 2, 1, 0. Look at my back seat exponents, 0, 1, 2, 3. Check, check, check. All flight checks are completed. Then, whew, cats and dogs. Good thing we're in here, huh? Put my little bins in because Mrs. Talbot really wants an A bad because, I mean, that's actually true about me. That's a 1. 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 Okay, now because this has stuff in parentheses like this, I'm gonna take 2 steps to simplify. I'm not gonna try to, rogue simplify in a 1 step. 2x quantity to the 3rd power is 8x cubed. I need you to pause there and really understand why it's 8x cubed before I move on. What is 2 to the third power? If you want, if it helps your brain, just go like that. Put little baby distribute lines there if it helps you. I just go on the calculator and go 2 to the third. Okay, plus 3 times 4x squared times 3. Do you see where the 3 went? 4x squared and 3. If you're going to mess this up, somewhere in here, it's going to be you're not squaring the number in front. If you're going to mess up, that's going to be where it is. Just, you know. 3 times 2x times 9 plus 27. Okay. 8x cubed plus 12 times 3 is 36, right? 36x squared plus 54x plus 27.